Hi viewers, myself Dr. C. Vijay Kumar, Associate Professor, Department of Mechatronics Engineering, K.S.Rangasamy College of Technology, Tirunelveli. Today we discuss about the model of liquid-based additive manufacturing process. So what is the liquid-based additive manufacturing process, how it's functioning, what are the different processes under the liquid-based additive manufacturing process. These are all the content we are discussed today. We see one by one. First, what is the liquid-based additive manufacturing process? The liquid-based additive manufacturing process is one of the additive manufacturing technique which deposits a liquid or high viscosity material onto a built surface to create an object which then vulcanized using heat or harden the object. Finally, we get a solid model of our final product. Most liquid-based additive manufacturing systems which builds the parts in vat of photocurable liquid resin and organic resin that cures or solidifies under the effect of exposure to light, usually in the UV range. The light cures the resin near the surface, forming a thin hardened layer. So these are the classification of RPT. Already we discussed about these classifications. Once again we will remember and repeat. The RP technology is classified in three types: powder, liquid and solid. But today we discuss about the liquid category. In this liquid category we have two classification. One is the inkjet, another one is the photopolymerization. But today we discuss about the photopolymerization category. The photopolymerization, again we using different types of laser we are classified. One is the UV laser, another one is the normal laser. Then the laser category we discuss about the stereolithography process. In our model we discuss about the stereolithography process. The acronym is SLA process. In step-by-step rapid prototyping process we already discussed, but now we go through the what are the step-by-step RP process in this rapid prototyping. First one, we create a CAD model. By using any drafting software used to create a design. Then next, the design CAD drawing is converted as a triangulation language, that is a STL file, standard tessellation language file. We convert a diagram into STL file. After that, we generating the support structure. Suppose if you need any support structure in your built prototype, you can create. Then we go for the slicing process. The slicing for the STL file of our CAD drawing, we can slice according to user size. This slicing process is completed. Once the slicing process completed, next we go for the laying out the generation process. The entire layout we have created. Then next you go for the machine part, that is a generating manufacturing process. If you use any type of machine, standard stereolithography machine or LOM machine, whatever it may be, use it. In the generative manufacturing process step, you complete your creation process. Once if you create the model in using your RP machine, next you go for the cleaning process, then post curing process, then finishing painting and any aesthetic process we can create this step. Once if you completed all the process, next you go for the finished product. Next important thing you see, first one is a CAD model creation. Next, all the three processes are under the pre-processing process. What are the three processes? STL file conversion, generating the support structures, slicing, layout the generation process. These all come under the pre-processing process. Once if your pre-process is completed, next you go for the generative manufacturing process. Once if you completed the generative manufacturing process, next you go for the post-processing. What are the process under the post-processing? Cleaning, post-curing, painting. If any add-on on aesthetic, we made it. That post-processing process. Once if we completed the CAD creation, then pre-processing, then manufacturing process, then post-processing, finally we get a finished product. These all are the step-by-step rapid prototyping process. Then next one, we see the rapid prototyping process, how the CAD model creation is converted to generation process. First we create the solid object of a 3D model using any drafting software. Next we go for the slicing process. The slicing process, according to the user, we slice in different sizes. Then go for this slicing, then converted as a generation process. Each and every slice we can manufacture. This is the RP process. Next one, we see one by one. First one is the stereolithography process under the category of liquid based additive manufacturing. What is the principle behind that the stereolithography process? The basic principle of stereolithography process is selective curing of photopolymer resin using a UV laser. In stereolithography process, very simple concept. Once if you use the photopolymer resin, the photopolymer resin is adapted using a UV laser. Once the UV laser is hit on the photopolymer resin, automatically the resin is converted into a solid object. This is the basic process. A thin layer of liquid resin is prepared in the machine build space. The laser draws a pattern on that layer, curing only the shape desired in the first layer of the model. Once the first layer of the model is created, next the cycle is repeated until the final layer is complete. This is the principle of stereolithography process. What are the materials used in the stereolithography process? This is very important. Standard resin used for general prototyping, engineering resins for special mechanical thermal properties, then dental and medical resins for biocompatibility certifications, castable resins for zero ash content after burnout. Then what type of laser used in the stereolithography process? The stereolithography system uses ultraviolet laser is used to solidify the liquid resin. The basic principle of stereolithography process is solidify the liquid resin by using UV laser. This is the principle into the desired form to defined by the CAD file. Next one is this is the stereolithography entire setup. You see, this is the reservoir, the reservoir containing vat. This is the bottom one is the support structure. Then next one is this is the container, that is the reservoir. The container contains photopolymer liquid resin. This is the movable strad. The movable strad is fixed on a permanent arm. Then top one is the laser unit supplying forum. This laser unit is fully controlled by servo motor. Where the laser is hit on the liquid resin is defined by servo motor. It's based on the requirement, user requirement, then STL file requirement. Once the process is started, the laser is supplied, the laser rays is supplied to the liquid resin. Where the laser is hit on the liquid resin, at that place is converted as a liquid to solid. Once the solid process is completed, we get a final object. The first layer is completed, then the movable strad moves downward into the x-axis, then next layer is formed, then the movable strad is moved down, then third layer is formed until the process is repeated once the complete object completed. Okay, this is the stereolithography process. Then next one, you see the step-by-step process of stereolithography process. You see the 3D diagram. The first layer, suppose if we created the first layer, the movable strad is up to top. The first layer, the laser is hit into the liquid. The first layer is formed. Next, the movable strad is moved downward. Then next layer is formed. Then it's moved down. Then third layer is formed. Until the complete layer is formed, the process is repeated. Next one, SLA process. The generation, these are the how the principle, how the working is carry on, that the entire detail is given. Then next one, the advantages and disadvantages. What are the advantages of SLA? What are the disadvantages of SLA? The advantages of SLA: relatively fast production, then good for complex models, scalability is simple, no human factor, no wasted materials. Then it's used in a biomedical application also. Each and every process we are having some disadvantages. In the same line we are having some disadvantages of SLA. That is the stereolithography process. There are only a limited number of materials available using stereolithography. Then parts are affected by moisture, heat and chemicals. Then limited photosensitive resins are used in stereolithography process. This is the disadvantages of stereolithography process. In next module we discuss about solid based additive manufacturing process. So take home points: The liquid based additive process, we discussed about the first one is a stereolithography process. It's based on the laser additive manufacturing process. Okay, thank you. In next class we see about the solid based additive manufacturing process. Thank you for watching.